Hey guys, this is lesson 10.4 for Academic Challenge Pre-Calculus. We're going to go through this. Some of it's going to seem familiar. This is similar to things we've done before because we've done systems of linear equations, but we have not done systems of nonlinear yet. So just kind of give you an idea, I'm not going to read this verbatim, but we're just looking essentially for the intersection points of the functions. So, or I shouldn't say functions, the expressions. So, let's say we were going to solve this system of equations. So, again, sorry, the work is not coming out step by step like I want it to, but we're going to work through this and show how this goes. So, some of the problems are like going back to how you learned how to solve systems of equations. You're going to find some methods are easier than others. This particular problem, it's easiest to solve it by substitution because you have this one with the squareds here, and then you have this one that's linear. So we're going to solve the linear one down here. We solve it in terms of x. So divide by that -4, you have y equals 3/4 x. Then what we're going to do, here's your new expression for y. Follow the arrow up, we're going to plug it in for y. So we're going to go down here and see where I'm at with the little arrow. So we plug that expression for y in here. We go ahead, solve the whole thing out, and we solve it for x. We end up with x squared equals 16. So always remember, you got to account for the positive and negative roots when you take a square root. So we do that, and that gives us two possible solutions for x. So in the end, you have to remember, if you have two possible solutions for x, we're going to take that. That's why there's this arrow here. We're going to plug it in for that expression for y. So here we plug in the +4. Here we plug in that -4. And out comes two separate answers for y. You can see over here in the solution, we have +4 gives us +3, -4 gives us -3. And it's neat to visualize. We can see how exactly that works. It's just a line and a circle, and it crosses right through. You'll find all different types of these equations. So looking at this one, we have a line and a parabola. So how are we going to start? We're going to use substitution. Let me back it up because my writing is kind of not right where it needs to be. So if we use substitution, we start off, we're going to solve for, or this one's kind of nice because it's already solved out. So y is already solved. We have y equals 3 minus x squared. So we plug that right in here for y, and this is our new expression that we get. So what happens is we come out here and rearrange, and we get something in standard quadratic form. Now, I know you already see the no solution. When we get to this point, obviously, try to solve it with factoring or something, that's going to be faster to begin with. And then if that does not work out for you, you can go ahead and plug it in the quadratic formula. If you forget how to factor, just use the quadratic formula because remember, it always is going to work. So when we do it, we get a square root of a negative number. So we're looking for real solutions, not imaginary, and thus that's how we determine there's no solution. The interesting part is, again, this is all applicable. We can see why there's no solution because they actually never do intersect. So here's another one. We have a hyperbola and we have an ellipse. So we don't have to worry about getting these in standard form or anything like that. This particular one, though, if you notice, you can line them up, and we're going to do this by elimination. Remember when you multiply by a number to get something to disappear? So we multiply this bottom one by a 5, and that's going to make us have a -5y squared, a +5y squared. So when we combine them together, here's the two equations. So I multiplied the bottom by 5, which gives us a result of 15x squared minus 5y squared minus 5. So when these two cross off, we're left with only x. So we have 17x squared, we add those together, equals 34. Divide through by that 17, we get x squared equals 2. So that means x equals plus or minus square root 2. So remember when you back in the days when we first learned how to do our solving by elimination, you always have to go back and just plug it in one of the equations. It doesn't matter. So we're going to plug, now notice here I plug the plus or minus in for the squared. That's because when it's squared, the plus or minus does not matter. So what ends up happening is we actually get 4 solutions in the end. So we plug that in, solve it out for y, and we get y equals plus or minus square root 7. So what we're saying is that when x is positive or negative square root 2, we're going to get the possibility of positive or negative square root 7. So notice there's 4 solutions. So we have the positive, positive, negative, positive, positive, negative, negative, negative. So you have to account all 4 of those. It's going to mess you up in the homeworks because I remember we've had many issues in the past where people only put 2 of those solutions in there. If you only get 2, just make sure you let me know, show me your quiz work, and I'll go ahead and give you partial credit. But make sure still you have to take both attempts to get that. Here's a picture, and I know sometimes in your head it'll be like, how in the world can there be 4 solutions? But you can see, it really just depends on the function or the expressions we're dealing with. So here's another one, solve the system. So this one, most of them, substitution is going to be the easier route. So we're going to go ahead, pull this second one, and we're going to solve it for x in terms of y. So we have that. Then we take this and plug it in for x, and you can see it right here. So we do 3 over y squared minus 3y squared. Now there's a little bit of math going on here, so we square it. This jump here, this is why I wish I could just step-by-step show this to you. So see this jump here where my cursor is, where my little arrow is. We multiply the whole thing through by y squared. So that's why this becomes 9. This becomes y to the 4th, and this becomes 6y squared, because we're multiplying that through. It's like getting a common denominator. But remember, once you multiply it through, that denominator obviously doesn't matter anymore, so we're just multiplying the whole thing through by y squared. So bring this down, and ran out of room there. We rearrange it, we factor it. Remember these factoring problems where it looks like a quadratic even though it's not? We have y to the 4th, y squared. So we factor that, and now what are we left with? This first one, there's no real solution, so we don't even have to worry about that. And then we just look at the second one. We have y squared minus 1, so you can either factor this difference of 2 squares, y plus 1, y minus 1, or you can just solve it out. Add the 1 to the other side, take the square root, you get plus or minus 1. So we have 2 possibilities for y, and then you're going to plug that back in here. So when you plug in your positive 1, you get positive 3. When you plug in negative 1, you get negative 3. So we have x equals plus or minus 3, and it's consistent with y being plus or minus 1. So we have either positive 1, positive 3, or negative 1, negative 3 as our solution. Okay, here's a word problem. So we have a student recreating a college, essentially skipping through all the information that's kind of unpertinent. We have a rectangular piece of land that has a perimeter of 204 meters and an area of 2,565. So we have a perimeter and an area. So we need to find dimensions. So the first thing, obviously, you always want to make a drawing. So here's our drawing. We don't know what the length and width are. We know total that the perimeter is going to be 204, but we know our area is 2,565. So translate it. Remember, formula for perimeter is 2w plus 2l, 2 width plus 2 length equals 204. Then length times width equals 2,565. So we take those 2 equations, which are right here, and we're going to do substitution. So we solve for w in terms of L, and we plug that in the original. So you can see that right here. Here's w in terms of L plugged in, and just a lot of math. So everything's divided by 2, or we divide everything through by 2, kind of like factoring. It just makes it easier and more simplified. We're left here. Just like the last problem, we multiply through by L. So we get this, and now we come up with something that looks quadratic in nature. You don't have to try to factor stuff like this. More than likely, it's not going to factor, as you can see here. But we plug that into the quadratic, solve it out. Out comes this value. now I told you to account for positives and negatives, but this is real world now, so we're not going to worry about negatives because we can't have negative dimensions. So this is our length. We take that up here and we plug it in to find our width, and we get a width of 20.88. Sorry, I didn't put it as a coordinate point. So this is the length, 122.87, width is 20.88. Obviously, in homework, just make sure that you account for the rounding that it asks you to do. And then this is, I think this is actually going into the next section. I'll just lump them both together. I think it'll be a short enough video. So we have graph the solution set. So remember, when we do inequalities, we have to pick the test points. So we have two systems of inequalities. You're going to go ahead and solve them the same way that you solve the system of equations. Okay? So the math is kind of, here, there's the picture. This is kind of like detailed out, and this will be in your notes that I have available for you, the ones that aren't filled in. So you can see this was already the one that we had solved, and this just kind of shows how you would do it. So you would pick a test point. Obviously you can't pick 0, 0 because this line crosses through there, but you could pick, like, 0, 1. Plug it in, and you're just going to shade those regions according, and wherever the two regions intersect, that's what you see there in the dark blue. I'm sorry, that's shaded both red and green. It's not green, it's blue. The colors are a little off, but it's this double shaded region here that is your region. If you struggle at all with this, I know this is kind of a poor example, let me know, send me an email, send me a text. I can work some more problems for you. We can even Zoom or do it in the Zoom session, and I'll actually draw out some problems for you so you can see, or help you work a couple problems. So just let me know if you have any issues with this. It's just difficult to do through the PowerPoint. Okay, that's right. It's parametric equations is next, so I'm going to end here for this lecture so the videos aren't too long, and then the next PowerPoint will be 10.7.